Hello. So in this section, I'm going to tell you about types of probability distribution. Since we have already discussed why we require probability distribution, and we discussed, let's suppose we have a data and data is in a huge amount, and somewhere any amount of data is missing in our distribution. So rather, checking that value, we can visualize our data and we can look into that where our data is missing. Okay, so that is why we require probability distribution, and how we can understand this, we have already gone through. So there are different types of probability distribution, and few are discrete and few are continuous, and I have already described like how we can categorize that. So let's start discussing with normal distribution. So well, if I say about normal distribution, so normal distribution is a kind of distribution where the curve, when the data is distributed, so the curve, is generally bell curve, and means where mean is equal to median equal to mode. So data here is almost, distributed throughout the confirmed from the mean, and that is why theta is symmetrical in this condition. And most of the time, the area is normally distributed curve falls between the standard deviation 1 of the mean, and 95% lies between 2 standard deviation of the mean. So this is the case, is called normally distribution in data. Now moving further, let's talk about Poisson distribution. So when is a Poisson distribution? So Poisson distribution, we can understand that, when we have a, multiple event occur, right? So even in multiple event occur, we can, have different data and their frequency distribution there. So in Poisson distribution, there are multiple event can be counted in a whole number, and the relationship between the frequency distribution is there is no correlation. If I tell you about Poisson distribution with an example, let's suppose, in an we are working in a call center. Let's take an example of a call center data, and in this call center we have different records we are taking. So in an entire day, let's say we get x number of calls. Okay, so in the x number of calls, let's suppose we get call that is for emergency calls, for the number of emergency calls recorded in a day, in which few calls are for theft in that area, few calls are for saloon uh, slot booking, few calls we have for suicide reports, and few calls we have for let's say there is an error in printing book error. So let's suppose this is generally different types of calls we get in a call center. So what I'm trying to tell you, we can understand from this example about Poisson distribution that Poisson distribution is applicable in any situation where event occur at random point of time and space, wherein our interest lies only in the number of occurrence of the event. So a distribution is called as Poisson distribution. And when the following assumptions are valid, that any successful event should not influence the outcome of another successful event, the probability of success over a short interval must be equal the probability of a success over a longer interval. And the probability of success in an interval approaches zero as the interval becomes smaller. So, that is what mentioned here. It is Poisson distribution determined by lambda, and lambda is the rate at which an event occurs, and at the time, in a time frame, the event occur is the length of a time interval, and x is the number of event in that time interval. So we can say that um, you know that a Poisson distribution can be defined as the mu here is lambda into t. So mu denote as a mean here, lambda t, mu is a mean here, and so lambda is a rate at which this event will occur. So this is what we can understand about the Poisson distribution. Moving further about binomial distribution, we can understand binomial distribution with a significant example that, let's suppose, you know uh, we can take an example of like playing in a cricket, and let's take this example that every day, when we before we start, there is a series of matches we have, and let's suppose that we won a toss today to proceed for a batting first or bowling first. It indicates a successful event. So we toss again, but we lost this time. If we win toss today, that does not mean that we will win the toss tomorrow. So that means the same process, we can take an example of tossing a coin, that let's suppose you toss a coin for 10 number of time. That does not mean that every time you will get head or a tail. So in a binomial distribution, we call one of any probability of a success denoted by P is same on every trial, and these trials are independent. That is, outcome on one trial does not affect the outcome of other trial. Okay, so that is why binomial distribution can be defined as probability of x will be based on n epsilon. That means for n number of time the event occur, that is n minus x epsilon x epsilon, that is px q n minus x, right? So probability probability of failure can be easily computed. Q is a failure, that is nothing but 1 minus p, and we have probability of winning is, we know that is again are the event that we going to find out. So here is P and Q, we have two assumptions that we're going to make: probability of getting head, or probability of not getting head, or probability of getting pass or not getting pass, failure and success. I hope you understood. Now moving further, let's talk about chi-square distribution. So basically, chi-square distribution is the mean of chi-square distribution is equal to the number of freedom equal to mu equal to v. Mu equal to v. So this is the equal degree of freedom of this chi-square distribution. That means the variance of distribution is equal to twice the number of degree of freedom, that is the beta 2 equal to 2 into v. So the maximum value of y occurs when degree of freedom is greater than or equal to 2, implying chi-square is equal to v minus 2. The chi-square curve approaches a normal distribution as the degree of freedom increases. Example, women are twice as likely to vote for a party than men. Similarly, if we have to understand about t distribution, so the mean of t distribution is equal to 0. This is also somehow symmetrical, but in t distribution, the variance is defined as v by v minus 2, where v is the degree of freedom. The variance is always greater than 1, although it is close to 1 when there are many degrees of freedom with infinite degree of freedom. So the t distribution will approach a standard normal distribution that college student grade point averages when we find, and that is the average t distribution. Then we have a f distribution. So F distribution, there are some certain characteristics that basically into, F distribution is into positively skewed kind of thing. So the curve of F distribution depend on the degree of freedom, where V1 and V2. The mean of distribution is equal to V2 by V2 minus 2 for V2 greater than 2. And this is the variance. We can understand the example of F distribution that there is a variance between two professors grading same exam. So when we have a two different kind of distribution on the same data based on different frequency distribution is called F distribution. We have also discussed this approaches of normal distribution and standard normal distribution. So we discuss this normal distribution when our data is generally a bell curve. So when we talk about the data is normally distributed by mean, is called normally distributed normal distribution. And when it is distributed toward standard deviation, is called standard normal distribution. So the formula of standard normal distribution is Z equal to X minus mu by standard deviation. So X is the score of the original normal distribution and mu is the mean of the original normal distribution, and delta is the standard deviation of normal distribution, and the standard normal distribution is sometimes called as Z distribution. So the Z score always reflects the number of standard deviation ever below the mean. So this is what about all distribution, probability distribution.